In this video, we're going to talk a little bit about amines, And these are just organic compounds where you have a nitrogen bonded to groups that contain carbon. So if I were to just draw some amines right here, you could have something like this where you have a nitrogen bonded to two hydrogens, and then maybe some type of carbon chain. Maybe it's just one carbon right here. So maybe you have a carbon which is also bonded to three hydrogens like this. In this case, you would have a primary amine. If you have the nitrogen bonded to two carbons, so if you have something like this, a nitrogen bonded to two carbons, so it has one carbon chain right there. And I'm just drawing methyl groups here because the chain could just keep on going. Maybe you have two like that, and then you have a hydrogen right there. This would be a secondary amine. And then finally, you can imagine if you had it bonded to three, it would be a tertiary amine. And this is just to get you introduced to the terminology. CH3, just like that. Now, like all of the other new groups or new types of compounds that we've explored, what I want to do is just introduce you to the naming of it. Because one, that lets you recognize them when you hear their names, but it also, I think, on some level, familiarizes you with their structure. So let's do a couple of naming examples. I drew these ahead of time. And in general, just to remember, amines are a pretty high priority group. Out of all of the things that we've learned so far, the only thing that is a higher priority is actually the alcohols, or actually the thiols, which I don't even remember if I did a video on it, but thiols are just like alcohols, but instead of an oxygen, you have a sulfur. So this comes right after those. So let's think about this one right here. So we always want to look for our longest carbon chain. And our longest carbon chain is right here. 1, 2, 3, 4, 5, 6, 7 carbons. You want to start numbering it closer to the functional group. 1, 2, 3, 4, 5, 6, and 7. And then the functional group is on the 2 carbon right there. So first of all, 7 carbons, we would use the prefix hept. So it would be heptan. Let me write that down. So it would be heptan. Heptan. And since our functional group is an amine in this situation, it has a higher priority than the fact that this is an alkane. So this will actually define the suffix. This will define the suffix. So we would then say, well, then on the 2 carbon, let me do this in a new color. On the 2 carbon right over here, we have the amine group. So it's heptan 2 amine. Heptan 2 amine. And we're done. We know that we have an amine group on the 2 carbon. Now let's do this one. This one's a little bit more hairy. So first of all, we always want to figure out the longest carbon chain. And it looks like the ring is going to be the longest carbon chain. We have 1, 2, 3, 4, 5, 6 carbons. So this thing right here is the longest chain. We only have 1, 2 carbons right there, 1 carbon right over there. So our root is going to be cyclohexane. So our root is going to be cyclohexane. I want to make sure I have enough space. Cyclohexane. And then once again, it's an amine. So this is going to take higher priority. So we're not just going to put an E at the end and call this cyclohexane. This takes higher priority. So it'll actually define the suffix. So and another thing to think about is you could say, okay, this is going to be the one carbon. And so you could call this cyclohexane 1 amine. But in general, if this is defining it, you always assume that you're going to start numbering right there at number 1. So you could just call this cyclohexane amine. Hexanamine. If it's written like this, you assume that the 1 carbon is where the amine group is attached. Now, what else do we have on this thing? We took care of the amine. We took care of the cycle. Well, we have this ether right here. And this ether has 1, 2 carbons. If it was just a 2-carbon chain, it would be ethane. But since it's an ether, it's bonded to this oxygen, we call this ethoxy. So that right there is ethoxy. And we're going to have to think about how we're going to number this. So I'll leave that alone. And what are these over here? Well, this is a methyl group. That's a CH3 implicitly. You don't see it drawn, but there's a carbon there, and all of if carbon is neutral, it has to have 4 bonds, and if you only draw one of them, the other 3 are assumed to be dihydrogen. So this is a methyl group. This is a methyl group, and then this is also a methyl group. This is also a methyl group. So we have dimethyl. So this is also a methyl group right over there. And when we think about numbering, we could number from 1, 2, 3, or we could start numbering 1, 2, 3. And in general, you want to go numbering in the direction where you hit the functional group first. So we want to go 1, 2, 3, 4, and 5. So this right here is 5-ethoxy. This is 5-ethoxy. And then this is 1,2-dimethyl. These two combined, you would call this 1, 2 dimethyl. And then when you want to list them in order, the ethoxy would take precedence in alphabetical, because the di you shouldn't count in the alphabetical order. You're really looking at, this is just saying 2 methyls. So you really just want to look at the 2 of whatever you're talking about. M comes after E in alphabetical order. So this is going to be 5-ethoxy. Actually, let me just rewrite the whole thing. So this is going to be 5-ethoxy, 5-ethoxy, 1,2-dimethyl, 1,2-dimethyl, dimethyl, cyclohexanamine, cyclohexanamine, and we're done. And we're done. This was probably one of the longest words we've used in naming, but hopefully you see when you break down the different pieces, it actually makes sense that it represents this molecule.